Hey guys, it's Leia. Today we will talk about how to prove trig identities. Proving trig identities is tricky because there are multiple ways to do this. Good thing to note is to review the previous video on simplifying trig expressions because some of the same methods and tips are applicable. In order to prove identities, you want to show that one side of the equation can be transformed into the other side of the equation. You can work on both sides of the equation, but you cannot work on them at the same time. It will make things very tricky. You want to start on the side that looks more complicated. If you can't decide which side is more complicated, pick any side. If it doesn't work out, then pick the other side. Like simplifying trig expressions, you want to rewrite the trig functions in terms of sine and cosine. This might not always work, but it will work often. Determine if you need to break up a fraction or combine fractions based on what the other side of the equation looks like. If needed, multiply by 1. Also, if needed and possible, factor. It is a little tricky, but let's see some examples. First example, we have cotangent of x over cosecant of x equals cosine of x. In order to prove this identity, I find it easiest to make a t-chart to help organize things and see which side of the equation you are working on. We want to work on the side that looks more complicated. In this case, it is cotangent of x over cosecant of x. Like the tip says, we are going to rewrite all trig functions in terms of sine and cosine. Next, we will use this identity to simplify, so we get this. Next, we simplify by canceling out sine of x, and we get cosine of x, which is what we are looking for. Since we've reached the result, we are done. Next example, we have cotangent of x plus tangent of x equals secant of x times cosecant of x. We will set up a t-chart again. Next, we pick the more complicated side. In this case, it's cotangent of x plus tangent of x. Like the last example, we will start out writing all the trig functions in terms of sine and cosine. Next, we want to make a common denominator to combine the function. Next, we simplify and combine the fractions. Next, we use this identity to simplify. Now, by looking at the result, we want secant of x, cosecant of x. We are going to want to split the fraction into 2. Next, we simplify and get secant of x times cosecant of x, which is the result we want. Last example, we have sine of x to the 4th minus cosine of x to the 4th equals 2 sine of x squared minus 1. We will add the t-chart. Now we will pick the more complicated side. In this case, it is hard to tell. So we are just going to go with the left side because we can see that there is a difference of squares. So first, we will factor. Next, we can simplify using this identity. Now, by looking at the result, we want 2 sine of x squared minus 1. We want to have only one sine function, so we will rewrite cosine of x squared. Next, we simplify by distributing the negative 1. Then we simplify again, and we get our answer. Proving trig identities is very difficult because there are so many ways to solve them. The way to get better at this is to keep practicing. For more help or practice on this topic, visit www.symbolab.com and click on the Practice tab.